Hello students, Assalamu alaikum. Today this is lecture number 3 for SAT Maths, and what we're going to discuss is parallel and perpendicular lines. This is a repeatedly coming questions in SAT Maths. So for instance, this is x and y axis if you see, and in this case, just a minute. In this case, if you see, this is a straight line AB. It has gradient y2 minus y1 upon x2 minus x1, and that's also known as slope, right? So when we say that we have parallel lines would mean, suppose these two lines are parallel, they never intersect. This has gradient m1, this has gradient m2. For example, this is having gradient 3 by 5, this is also having gradient 3 by 5. So m1 will always be equal to m2 in this case, right? Similarly, if two lines are perpendicular, that means they intersect each other, and at the point of intersection, angle made is 90 degrees. These lines are known as perpendicular lines, right? So what happens for this? What is the situation? Geometric condition for these are, this is m1, this is m2, so gradient would be negative reciprocal. Suppose this is m1, this will be equal to minus 1 divided by m2. For example, this is gradient 3 by 5, this line has gradient 3 by 5, this will be having minus 5 by 3. You see, we have flipped it and we have changed its sign as well. Got it? So in our equation of straight line, we know that it's always y equals to mx plus c, where m is slope and c is the y-intercept. In order to identify different gradients, suppose if it is y is equal to 2x plus 6, right? If it is written y equals to 2x plus 6, it's clear that gradient is 2 for this case. But what will happen if we have 2x plus 3y is equal to 6? Now we will have to make y the subject, okay? Make y the subject. Okay, when we make y the subject, it will be 3y. So 3y equals to minus 2x plus 6, and then y equals to minus 2 by 3x plus 6 divided by 3. Now gradient is minus 2 by 3. So this is what we will have to do sometimes in order to identify what is basically gradient of a particular line. Okay, now let's solve some questions related to this topic. Here you go. Now this is, wait a minute, yes. So for question number 1, we have which of the following is an equation of the line passing through minus 4 and 1 that is parallel to 4x minus 2y is equal to 3. Okay, by the way, now when we have this straight line and it is parallel, so we know that when lines are parallel, they share same gradient. Okay, so first of all, what I'll have to do is we'll have to make this in this format. 2y equals to 4x minus 3. We have just rearranged it, 2y on right hand side and 3 on left hand side. So y equals to 4 by 2x minus 3 divided by 2. That will make it 2x minus 3 by 2. So this given line has gradient 2. Slope is equal to 2, right? In this scenario, you can see point A and B, options A and B have gradient 2. Now this line, what we are looking for, has gradient 2 and is passing through minus 4 and 1. So y equals to mx plus c. So y is 1 is equal to plus c. So 8 plus 1, 9. Value c is 9. So its y is equal to plus 2x plus 9, right? So y is equal to 2x plus 9. So y equals to 2x plus 9 is B. Option B is my answer, final answer. Similarly, in question number 2, we have, if you see in question number 2, it says Which of the following is an equation of the line passing through minus 4, 1 and is perpendicular? Now if it is perpendicular, this is the same line we have just discussed. So 4x minus 2y is equal to 3. So rearrange it in this form. It's 2y equals to 4x minus 3. So y equals to 2x minus 3 divided by 2. So this line has gradient is equal to 2. Now since our required line is perpendicular to given line, so our line will have gradient is equal to minus 1 by 2 and it is passing through minus 4 and 1. So required equation would be y is equal to mx plus c. Now y is 1, m is minus 1 by 2 and x is minus 4 plus c. It's 2, 1 is equal to 2 plus c, c is equal to minus 1. So it is y is equal to minus 1 by 2x minus 1. So minus 1 by 2x minus 1 will make it minus 1 by 2x plus 1. Minus 1 by 2x minus 1. It is option C. It is option A. It's minus 1 by 2x minus 1. Got it? So guys, our next topic is system of linear equations, and when we say system of linear equations, by this we mean that we have two linear equations. Generally it is of this form: ax plus by equals to c, or we can write it as y equals to mx plus c. So case number 1, if it is y is mx plus c, y is equal to mx plus c. So m1, this is m2, this is c1 and this is c2. Remember, whenever we we come across two straight lines, these are possibilities that may happen. Okay, they may intersect at one point, they may be parallel and they may show no solution, or they must be overlapping lines. Okay, first of all, it is we call it one solution. They intersect at one point. Okay, they intersect at one point, one solution. Second case is they will have no solution. What do you mean by they will have no solution? The lines parallel will have no solution. And case number 3 would be they will have infinite many solutions. Infinite many solutions. Okay, when we say infinite many solutions, we say that lines are basically overlapping. Okay, both lines are overlapping and they share same. So every point is a solution to them. Okay. Now, when they'll have one solution, that means lines are not parallel and m1 is not equal to m2. So if two lines are there such that their gradients are different, it is show that they will have one solution. Okay, no solution, it is when lines are parallel, m1 is equal to m2. It is just like this is intersection and this is it. Line 1 and line 2 are having same gradients, but c1 is not equal to c2. That means their point of intersection is different. Suppose this is line 1, this is line 2. Lines are parallel, but c1 and c2 points of intersection with y-axis, or in simple words, y-intercept is different. We say that lines are different. Okay, and they will never meet at this point. Third case is case number 3, infinite many solutions they have. So when we say infinite many solutions, that means the lines are overlapping. They're having same gradient. Number 1, they're having same y-intercept. Okay, so that means suppose this is your x and y axis. So this is your line 1 and the same is line 2. Both lines are intersecting y-axis at the same time. So in general, if two lines, parallel lines, will intersect at one point, that is, the situation is m1 is different, m1 is not equal to m2. Okay, point of intersection you will get. If two parallel lines, if two lines have no solution, that means they are parallel and they do not intersect at any point. Third case is they have infinite many solution. That means they are overlapping lines. Okay, they are overlapping. So if equations are given in this form, y equals to mx plus c format, then these are the investigations you will carry out in questions to figure it out if given lines have one solution, no solutions, or infinite many solutions. Is that clear? I repeat, if equations are given in this scenario y equals to mx plus c format, then you will have to see if slopes are different, they will intersect at one point. If they have no solution, that means lines are parallel, they will have same gradients, slope 1 slope 2 would be equal, but c1 will be different from c2. And third case is infinite many solutions. That means that lines are overlapping and they are intersecting at one point on y-axis. Second case is, what if we have equations given in this form, like it's ax, wait a minute, plus by is equal to c, a1x b1y c1, a2x plus b2y is equal to c2. Now first of all, let's discuss case number 1, that is one solution. What do you mean by one solution? That lines will intersect at one point. Suppose this will be the situation, right? In this case, a1 over a2 will be different from b1 over b2, right? a1 over a2 will be different from b1 over b2 in this case. Case number 2 or situation number 2 will be no solution. Two simultaneous equations have no solution only when they are parallel. Okay, so when two lines are parallel, suppose this will be the scenario. These are lines which are parallel, they have no solution, right? So in this case, a1 over a2 will be equal to b1 over b2, but it will be different from c1 over c2. So no solution means lines are parallel, but they intersect y-axis at different points. c1 and c2 are slightly different. And in third case, when we say that infinite many solution, case number 3, when they have infinite many solutions. Infinite many solutions means lines are overlapping. Okay, lines are overlapping, that means a1 over a2 is equal to b1 over b2 is equal to c1 over c2, right? So it goes in this way. Yes, lines are totally overlapping. So once lines are overlapping, every point is a solution, right? So that's why we would say that these are three situations if equations are given in this form, and these are the situations if equations are given in this form. Let's solve some questions related to this topic. Okay, so here you go, question number 1. Now in question number 1 we have just a minute. Yes, question number 1 we have is for which of the following values of k will the system of equation have no solution? So when they have no solution, that means it's 2 by 4 must be equal to 5 by k must not be equal to 8 by 17. So you would say, okay, 2 by 4 must be equal to minus 5 by k. So 2 2s are 4 and you cross multiplied, k is equal to minus 10. So D is the answer for this. Okay, have no solution, you should remember that we are applying for no solution this case. We are applying this case if two lines have no solution. So we would say a1 over a2, because now this is my a1, a2, this is b1 and b2, they must be equal, and you cross multiply it, right? Here is question number 2. If the system of equation have A or B are constant, if system has infinite many solutions, so what is the case for infinite many solution? That means 5 by A must be equal to minus 2 by B must be equals to 3 by 6. So what is value of A plus B? Now very easy, we are going to simplify it in this way. Okay, so 5 by A must be equal to 3 by 6 and minus 2 by B is equal to 3 by 6. So 3 2s are 6, cross multiply, value of B is minus 4, 3 2s are 6, value of A is 10. So they are asking for A plus B, you would say it's 10 minus 4, so 6 is your answer. That means A is your answer for this case. Okay guys, coming to question number 3. If the system of equations above A and B are constant, for which of the following value of A and B will the system have no solution? Okay, so when they have no solution, that means lines are parallel and they are intercepting at different points. So it must not be equal to 3 by A must be equal to B by minus 4, but not equal to 3 by 6 or 1 by 2. Okay, so now let's try values. That means these must be same, these two values must be same. 3 by A equals to B by 4, so it's X and this is Y. So this is A and B. So for instance, let's try putting the values A minus 1 and B2. So A minus 1 and B2 will be the case when they will have different solutions and they will definitely meet. So A is not the answer. B 1 and 1, same case, it will be 3 and minus 1 by 4, they will be having different solution and they will definitely meet. I cannot put 1 1 2 1. So 3 by 2 and 1 by 4 is also not the case. So by the way, 3 are not the option, so obviously it's D. Let's put it here. It's like 3 by 3 is equal to minus 4 by 4, that is not equal to 3 by 6. So 1 equals to 1 is not equal to 1 by 2. So this is the case that D is my answer for this case. Okay. Next question is question number 4. So here you go. It says in the system of equations above A is constant if the system has no solution. Again, they have no solution. What is the value of A? So if they have no solution, A over A minus 1 must be equal to 3 divided by A minus 1. But it must not be equal to 6 divided by 2. Okay. No solution always mean that lines are parallel and they intersect at different points. So let's put minus 3 here. So it will be minus 3 by minus 4 and 3 by minus 4. Okay, it's going to be minus 3 by minus 4 and 3 by minus 4. So it's different, they will intersect. For 1 it would be 0. For 3 it's 3 by 2 and it's 3 by 2 is equal to 3. We have option C here. We can put 3 here, so it's 3 by 2 is equal to 3 by 2 is not equal to 3, right? So these were some cases related to parallel lines. Next question of different topic. So when two lines are there, simultaneous equations, they will be having 3 situations: parallel, intersecting, and all. So these are the situations. Please revise these topics so that you may be able to understand them in a better way. See you in my next video. Allah Hafiz, take care.